For the 7.5 and 7.6 practice on 7.5, instead of typing it in the calculator, we're going to use the values that they give us for log of 5 and log of 7. So if we want the log base 10 of 35, we would break up 35 into 7 times 5 because we have 5s and 7s. So break it up into log 10 of 7 times 5, which according to our rules would be equivalent to log 10 of 7 plus log 10 base 10 of 5. We know the value of log base 10 of 7 is 0.8451. Log base 10 of 5 is 0.6990. So then when you add those together, you get 1.541. This is the part you need to show, how you broke it up, and then the replacement and the substitution for the values they give. For number 9, we're going to solve for n. We can take the 2/3 coefficient, move it to the exponent on the 8. So then we'd have log base 7 of n equal to log base 7 of 8 to the 2/3 power. And since we have the same bases, we can cancel those out. N would be 8 to the 2/3 power, or cube root of 8 squared. You can put that in the calculator either way. We can do cube root of 8 squared and you get 4. So you put equals 4 right here. For number 15, we have log 10 of r plus 4 minus log base 10 of r equals log base 10 of r plus 1. If we're going to solve for r, we can take this subtraction of the double log and make it a single log of division. Since it's subtraction, the r plus 4 will be the numerator, this r will be the denominator, equal to log 10 of r plus 1. So now we can cancel out the logs and we just have r plus 4 over r equals r plus 1. Then we'll multiply both sides by r. Once we multiply both sides by r, we get r plus 4 equal to r squared plus r. If we subtract r from both sides, then we get r squared equal to 4. And we take the square root of both sides, and r would be 2. For 7.6, we have the log of 6. You can simply put that in the calculator. Instead, we could just put it in the calculator. The log of 6, you get 0.77815. We're asked to round to the nearest 10,000th place. So that would be 4 decimal places, so 0.778, and then the 1, since this fifth decimal place is a 5, then that 5 is going to make the 1 turn to 2, so you put 0.7782. For problems 5 through 18, we're going to take the log of both sides. So for number 5, if it's 3x greater than 243 and we're trying to solve for x, if we do log of 3x greater than log of 243, then we can take the x exponent off the 3, move it in front as a coefficient, so then x log of 3 would be greater than log of 243. Divide both sides by log of 3. This will cancel, and we'll be left with x greater than log of 243 divided by log of 3. We can put that in our calculator. Close parenthesis before you divide. And we get 5. So x would be greater than 5. Sometimes we need to round. Sometimes you get a net decimal and you have to round to 10,000th place or 4 decimal places. Sometimes we get lucky like this one and get a whole number. Problem like number 18. We have 5 to the x squared plus 1 power equals 10. We take the log of both sides. Log of 5 to the x squared plus 1 equals log of 10. And you can move the x squared plus 1 out as a coefficient. Times log of 5 equals log of 10. Divide both sides by log of 5. So you get x squared plus 1 equals log 10 divided by log of 5. So what we'll do is once we get this amount in our calculator, we're going to subtract 1 from both sides and then take the square root of the answer. Log 10 divided by log of 5. Log of 10. Wait a minute. Let's go back. Maybe make this easier on ourselves. Log of 10 is what? Log base 10 of 10 should be 1. So really, we have 1 divided by log of 5 minus 1. We'll go ahead and put the whole thing in our calculator. Log of 10, close parenthesis, divided by log of 5. Get an answer. Subtract 1. Get another answer. We want to take the square root of that. So to keep from rounding, I'm going to try to type as much of the answer as I can. Press enter, and then I'll take that number and round it to the nearest 10,000ths place, so 0.6563. That 5 means I need to bump this 2 up to a 3, 0.6563. So x would be equal to 0.6563 for number 18. If we're given, like number 19, if we're given a log that's not in base 10, then we can write it as log of the outside number divided by log of base. We can put that in our calculator. And 1.7712. We don't have to change the 2 because the fifth number is a 4. For number 23, we're trying to find the pH of these different substances. The formula for pH is the pH is equal to the negative log of the number of hydrogen, positive hydrogen. So we plug negative log of 1.0 times 10 to the negative 1 into our calculator. Negative log of 1.0 times 10 to the negative 1. That becomes just 1. If we do the next one, sure, it'll be a little bit different. We'll put 7.94 times 10 to the negative 5th. If I do second enter, I don't have to type everything again, except for what I have in parentheses. And so in parentheses, I need to put 7.94 times 10 to the negative 5th. 7.94 times 10 to the negative 5th. Might have been easier just to start over. 4.10017. So if we're asked to round to the nearest tenth, round to the nearest tenth, then we would just put 4.1.